Thank you all for coming. I'll stand over here with you guys. Glad to have you all here. If you haven't signed up, sign in, please do so. Just a few things of note before we get going. We're on Facebook now, facebook.com/SBE 48. If you're on Facebook, go like the page. I've been posting the meetings and other info on there. The next meeting after today will be May 17th. Next month is NAB. We like to stay away from that. Jeff Welton will be presenting for us over Zoom, so it'll be an evening meeting. And then July 21st, Lookout Mountain Picnic.
Yay!
We'll have famous staves.
Yay!
And then finally, we're always looking for sustaining the groups to help sponsor our chapter and help with the catering and any other costs that we may have. So if you know of any companies, if your company wants to support us, contact me about that. Anyways, with that, Shane, you can take it away.
Can you make him full screen? Whoops.
Yes, I can take him.
Yeah, here we go. Let's see. Spotlight for everyone. There we go. How can he's there? How's that?
Good.
All right. All right. Well, I appreciate you guys having me. I really, I really enjoy talking about projects that we got going on and new technologies and all that stuff. I'm not going to bore you with PowerPoint poisoning, I promise. Mostly because I've been traveling and haven't had time to put one together anyway. But this is going to be kind of an interactive session, so I'm gonna call on you guys to answer some questions. So one of the things, the biggest thing we're going to talk about today is virtualization. It's a buzzword that you've probably heard a lot lately. Some people know exactly what it is. Some people think they know what it is. Some people have no clue what it is. So let me ask some questions. So show of hands, who thinks virtualization has to involve the public internet? Okay. Who thinks virtualization means that you're putting all of your stuff in somebody else's hands? Okay. And who thinks virtualization means you still have control of your entire plant? Okay. All right. So we're going to talk a little bit about that. The answer is, yeah, they're all right in some way or another to a certain degree. First and foremost, though, one of the biggest misconceptions is that virtualization. Well, let's talk first of all what virtualization is. What is it first? Put most simply, it is creating machines on top of a machine. In other words, you've got the actual physical hardware, but you have virtual machines running on top of that hardware through something that's called a hypervisor. And that hypervisor is what does all of the magic. Now, there are actually two different approaches to it. That's one that's probably the most common in terms of actual implementations. But the other one is running virtual machines on underneath an existing OS, like using things like VirtualBox or maybe on the Mac, you use Parallels, things like that. So that's the other style. That's not really what we're going to be talking about today, although that is virtualization, in fact. We're going to be talking about basically using a hypervisor. What's a hypervisor? What's a virtual machine? What's it take to set one up? Does it have to be connected to the internet, or can it all be in-house? Can I run all of this internally, or do I have to rely on some kind of external servers? So I'm going to try to answer a lot of those questions. And please, just speak up, interrupt me anytime if you have any questions. We'll go ahead and start. I will show off kind of one of the projects that I've been working on here. Let's see, share screen. Let's share my Chrome. Actually, I'll just share my whole desktop. I can go to Chrome. All right, so can you guys see that?
Yes.
Yep.
Okay, cool. Does my mouse cursor, can you see my mouse cursor too, or?
Yeah.
Okay, great. So I won't feel like a total idiot when I'm pointing at things and you don't see what I'm pointing at. All right. So this is basically what's known as ProxMox. ProxMox is its own little open source package that you install on bare metal on a machine just like you would install Windows or Linux or anything else. It's really kind of at its core, it is a form of Linux, but it's really very purpose specific to virtualizing other machines. So let's take ProxMox.com. So if you go to ProxMox.com, you'll see there it is, ProxMox VE 7.3. So they do sell a subscription for support. The software is free. I mean, if you're going to really use it in a serious enterprise environment in any kind of scale, I mean, I would suggest looking at getting a subscription, because then, I mean, otherwise it's just basically community supported. But all you would do is just go to downloads, ProxMox VE, which is virtual environments, what that stands for. We have a couple of other cool little products here too, but we won't get into those. So click on that. You can download ISO images. So if you want to install it from optical, or if you want to burn it onto a bootable USB, that gets a little bit more challenging, but it can be done. I mean, the ISO is actually designed so that it can be burned either onto a CD or onto a USB. I use a tool on the Mac called Elena Etcher. And I believe they have this available for both Mac and PC. But basically, you pick the file. I've actually got it downloaded on here. Probably not. Oh, actually, I think I do. Here we go, 731. So pick that file. I would select a target. I don't happen to have a USB drive in there. Otherwise, I would select the appropriate USB drive. Then I would hit flash, and it would do its thing. It's a 1 gig ISO. And when it was done, I would boot that in the machine that I wanted to install this environment on, and voila, as they say. And we'll go back to, once it's up and running, this is what you've got. You've got basically this environment here. It's called a data center because, I mean, essentially that's what it is. You've got a bunch of virtual machines in a centralized environment, which if these were physical machines, that would basically be a data center. So this machine actually, one of the other neat functions of virtualizing is that you can cluster these virtual environment hosts. So I actually have a really cool box that's got two completely separate sets of hardware. So completely separate CPU, RAM, motherboard, all of that. In a 1RU rack chassis. It's pretty insane in terms of the capabilities that are on there. So if we look, you can see here, cluster, it shows me the ones that are there. They also show up over here. Here's a summary of my system right now. So it shows that both my nodes are online, status is good. All of my VMs are currently running. So let's go ahead and start here. So I can bring up my one of my nodes here. I'll bring up node 1, and it shows me. So each of these is its own unique and discrete system that's running. I mean, it's to the point where you can even think of this as a giant KVM switch that I can access through a browser. So here, let's look at the summary of this node. So it'll show you it's got 48 CPU cores online right now. So this system actually has 96 cores of processing on the Xeon. It's a pair of Xeon processors on each of those nodes. I mean, it way overkill, but I just wanted to, have an environment where I could have as much room as possible to play with and just see what it takes. So each of the nodes has also got 128 gigs of RAM. We've got just shy of a terabyte online. Let's see, actually, no, this is almost 100 gigabytes, I guess, on this particular volume. But, there's more available that I haven't actually put online yet. So I mentioned that even though it is kind of a self-contained environment, it's still a Linux-based type of shell. So go in here, and this is basically it's Debian. It's Debian GNU Linux. So anything that would work on that environment would work on here as well. So look here, it just shows me it's let's see, the kernel 5.15 is 5.15. So But yeah, I mean, in the background, this hypervisor is actually a Linux system. So it's a Linux system that's hosting a bunch of other virtualized systems. I'm good here on my network interfaces. So I've got multiple network interfaces, so 2 physical network interfaces, and then a couple of bridges established. And we'll get to that in a little while. All right, so let's take a look. What do we have? What do we actually have running on this machine? Well, I have 3 packages or 3 virtual machines running on here right now. I have ScriptEasy, which is Automat's software for their remote controls. So this is basically a virtual remote control that I can access remotely. Right now, all I see is the actual root login or the login prompt for the OS that the remote would be running, and I don't really have root access to that. I would have to access it through their client software, which I can certainly do. So now if I look at, so each of those machines also has its own summary, so you can see the resources assigned to it. So this one's got 4 CPU cores assigned to it, 2 gigs of memory, and a 2 gig drive. It really doesn't use a whole lot, so we can actually scroll down here and see it's only using about 2% CPU. It's using just over 256 megs of RAM. You can see the network traffic that it's seeing here. So it looks like, oh, this must have been when I tried to log into it earlier. I forget what IP address it's actually assigned to, so I wasn't able to actually log into it. And then we can see what the disk is doing. Should show me my disk space too. Oops. All right. But like I said, you've got a console here. So like I said, this is basically a giant KVM switch for all these systems. And all you need is to be able to access that, that main system, and then you can get to all of these VMs from within a console here. I can even pop it up full screen here if I wanted to and act just as if I was at the console. Do that. We look at hardware. This actually shows the amount of hardware that I've allocated to that system. So you can actually configure the hardware that each of these VMs is going to run on and what's available to it. So here's where I told it it's going to have 2 gigs. If I wanted to give it more, I could certainly do that. Obviously up to the total amount available that's in the node, although you can also oversubscribe that. I don't recommend it. So for 1 socket, 4 cores for the CPU. It's got a default BIOS, a display, and motherboard, virtual SBE controller. The hard drive is just attached to an image that's stored on the system, which I can also move or reassign or resize if I had to. It's a virtual optical drive as well, so you could mount an ISO in there if you wanted to. In fact, to use a local one, tell it on local, and then I just pick whatever one I want. All right. And then here are my network devices for that system. I have 3 NICs assigned to it. They're all assigned to this bridge, so they're all on the same physical network that's available on that virtual bridge I showed you earlier here. So here's this bridge, and it's got an IP address of 142.201. So that's the system's actual IP address. So that's how I'm accessing it here in the browser, is 142.201. But I can assign anything that's on that bridge. I can assign anything within that network that's available if a system's attached to that bridge. So think of them almost as kind of your switches, your virtual switches within the environment. I have the second one I have here is actually on an AOIP network. So it's got a different IP address assigned to it. So, all right. So now let's look at my next machine here. This is my audio processing machine running Stereo Tool. I'm not sure how many of you are familiar with it, but Stereo Tool is a audio processing software made by Hans van Zutphen of Themio. Themio is this company, and it is quite impressive for the price. So it'll do your FM streaming, HD, It'll basically do one audio path with all of those processing types, plus, yeah, it'll send the MPX out over micro MPX. So this system actually has LiveWire audio coming in and micro MPX going out. And then the micro MPX decoder, which can be just a Raspberry Pi with an audio board on it, feeds my transmitter. And it works remarkably well. So again, here you can see the CPU usage. We've got 8 CPU cores assigned using 8%, 40% of the memory assigned out of 80 or out of 8 gigs, and a 32 gig drive. So there's the CPU usage and history here. It stays pretty consistent for the most part. And again, the hardware assignments. Now this one, you can see I actually assigned it to 2 different bridges. It was assigned to my main one here and my AOIP bridge. We'll get into that in a second here as well. All right, so let's go into the console. Put that up full screen. Need to turn, I really need to turn that off so it's not asking for the password every time. All right, so there it is. There's Stereo Tool running. There's no physical audio connected to this machine. It's just pulling this off of our audio over IP network. So if I go here to my I/O and look at my sound cards, look at my input, it says main input LiveWire plus AES67. And that's going to be a multicast address of 239.192.something that it's looking for. We can see the bar graph here shows that it's got good sync because it's solid. So if I drop that down, we could see that it actually has different types of AOIP that it can understand. Any kind of AES67, LiveWire style, Dante AES67. So if you've got a Dante network, you can actually feed this as well. It'll take a stream in VLC. It'll take any Linux audio device via ALSA. The advanced Linux sound architecture, which is a topic in itself. And then down here, we tell where that audio is going to come from. So the interface that I have set up, I have 2 of them on here. I have Ethernet 18 and 19. So once those are set up in the OS, I can go here and just tell it, okay, there's my AOIP network on that interface. I want it to be able to enable LiveWire Discover, enable Ravenna Discovery. I don't have any Dante. Now, it's for some reason this feature isn't working at the moment, but there is a way for it to actually pop up a list of channels. But otherwise, what you would do is just put your channel number in there. This channel happens to be 25111, which is my source for this audio chain. And there it is. And it's coming in, and there's the input, there's the output. See the oscilloscope, see my MPX here, and then all of my processing parameters. So you can also have a second input that is a physical audio card for one. A normal output. If I turn that on, it's probably not going to give me any audio. The FM output, which is, even though there's no physical audio device, it still needs that turned on for micro MPX. If I turn it off, see my MPX disappears down there in the corner. It'll do a low latency output for, but of course at the cost of more CPU use. And then here, micro MPX. So I don't have it enabled right now, but what it will do is basically spit out micro MPX to any number of IP addresses that I specify, or a multicast IP for that matter. So that's where you would set that up. And it actually will take bit rates as low as 320 kilobits and all the way up to 800 kilobits. And actually, I think it even goes lower than that now. I think this might be an older version that I need to update. I believe I had it down to like 176 kilobits in one case, and it still actually, I mean, you could tell, but it still sounded surprisingly good. You can also synchronize these various nodes with GPS. So if you're doing a booster network, it will support that. Show you the statistics. So right now, 344 kilobits is the average bandwidth that's off. The FM transmitter. Again, there we go. Oh, that's right. We already looked at that. This is where you can tell it to encode stereo, encode RDS, all that kind of stuff. So I do have it encoded RDS, although I don't have an audio or a data feed into it at the moment. So it's just the default. But yeah, so anyway, that's a quick overview of stereo tool. A really powerful piece of audio processing software, and not terribly expensive. I'd have to look again, but I want to say it's somewhere in the neighborhood of $1,000 for the software. And I mean, you can't buy a hardware processor for that price. Even by the time you add a PC to run it on, it's still a lot less expensive than the other options. All right. Questions so far? No? All right. Well, let's keep going. I think the next thing we'll do is we'll actually spin up a machine, show you how to actually set up a virtual machine. Well, let's try a Linux machine because I know those work great. Next. Back to that. Okay. Next. All right, here we go.
No such thing. I knew the 225 to 245.
All right, there we are. So those of you who've done Linux before might recognize this. So there's my Ubuntu installer. So while that's doing that, any questions so far? Have I lost you?
I have a question, Shane. So
Okay.
one of the things Steve and I were wondering is, how does it work with Windows licensing? If you were to create a VM with Windows, do you have to have a separate install license for each VM?
So yeah, it would work the same way pretty much that any other licensing for Windows installs would. So, and that applies if you've got like corporate licensing or anything like that. So it would basically treat it the same way, just like any other Windows client or server install. Which is why you notice a lot of these installs are Linux.
Yeah, precisely. And when we saw you do the Windows install, I thought, where is he? Is he going to get an ISO, or does he already
Well,
have it set up to Pixie boot?
You can download the ISOs and install them and evaluate them, but it'll nag you. So again, unless you've got licenses for production use, then Linux is probably a better option for that. And there's very little that you can't do in Linux that you can do in Windows. And it's actually a lot easier, especially if you use a desktop environment. A lot of people think Linux has to be done, all the command line, stuff that you see flying by down there below, but it doesn't necessarily have to be done that way.
Yeah, I have experience with Ubuntu, and I've used it for a few different things, but outside of some of the major available software, like what you see here, Spotify and VLC, trying to run something on it like a traffic server or a music scheduling program,
Right.
You're probably still going to be looking for Windows VM.
Yeah, I mean, you've got Wine and some packages, some applications will run under that, but it's kind of hit and miss. So yeah, in some cases, yeah, you're going to have to do Windows. But again, I mean, this is a great way to do it without adding, a bunch of physical hardware, and you get the bonus of kind of having this built-in virtual KVM. Oops. So I don't really want to set up live patch right now. Next. And done. So there, I have a fully functional Linux install up and running, and that took, what, maybe 5 minutes? And I can access it through my browser, through my hypervisor here. But anything that you can get at from a browser, you can get at from here. So, for instance, like let's look here. Say I want to get to one of my satellite receivers. I wonder if I've got that set up yet. Probably need to give it an IP address. So let's do that. Since this network does not hand out DHCP, let's go ahead and tell it I want 10.16.1.2. I'll call it null3 since that's the machine's ID. Right. DNS, we'll give the DNS server. There we go. Get down, back up, connected. So that, back to my browser. I go to Google. There I am. I'm on the internet, and I can go to my internal resources as well. So. Yeah. I love the self-signed certificates. So this is actually in a rack, just literally right next to the one that that my VM is in right now. So there's one of my satellite receivers. So I can get at that. So yeah, anything that's on your network within, you could use this as a bridge even between networks if you wanted to with those bridge interfaces. So yeah, if it's on your network, you can access it through your browsers here. But there you go. So here we go, and we look, and you can see what it's doing. It's summary as well. So I gave it a little less CPU, so you can see it kind of spikes a little bit there. But, and same with the RAM. But yeah. So there you have it. That's pretty much the basics of virtualization. Yes. Virtualization 101.
So I'm looking at this ProxMox and thinking, why would anybody use VMware?
Mostly corporate standards. I mean, there are a lot of IT guys who are just more familiar with VMware and with the ESXi. I mean, it really depends on your environment, what you're more familiar with. You can do all of this under ESXi and excuse me, and VMware as well. But I mean, if you don't have the budget for VMware or ESXi, and trust me, it is expensive. The project that I'm looking at is actually virtualizing things at transmitter sites. And I really can't justify spending the money on licenses for VMware, ESXi, just for transmitter sites, not at that cost. So,
what kind of machines at transmitter sites would you virtualize? Just
so
for example.
Well, in this case, like I said, I've started with audio processing and remote control. So you can virtualize an audio processor and a remote control already. You could virtualize your audio transport, your STL. So you could actually use this as a codec to receive the audio from your studio. You can virtualize various other monitoring functions at the transmitter site and just use it as a utility machine there to access things on site. So there are a number of possibilities. You can even use it as a firewall and VPN server if that's what you would choose to do. Certainly, it's certainly doable, certainly a possibility. Oh, I think you're muted there, Mike.
Oh, sorry. Yeah, I said that gives me some ideas, but I don't know if I would really want an STL running on a PC.
Well, think about it. How many codecs now are basically running an x86 board inside of them?
Yeah, well, that's a good point.
So
But
I mean,
they don't do updates every Tuesday.
no, that's the point here. I mean, especially with the Linux OS like this, you control how it gets patched, and that is an important point. You still do want to make sure these things are patched, but at the same time, you can do it in a more controlled or more managed function. Like even the hypervisor itself. So if I go back up here and take a look, and go to my node here, we'll go to my updates, for instance. It shows me that I have a whole bunch of updates here that could be applied. And generally, I mean, unless it's going to be like a big security thing or something that is affecting the functionality, I mean, don't fix it if it ain't broke. But certainly, yeah, you do want to keep, it is something that you want to pay attention to. But there are tools for managing all of that as well. So. Oh, I neglected to mention one of the coolest features of having this type of environment. So let's go back to my test machine here. So say you've got the machine exactly the way you want it. I go down here now to backup, tell it back up now, and tell it I just want to do a backup of the thing as it exists right now. There it goes. So it's going to.
So does that create an ISO that you can let?
It creates something that it creates a restore point basically, so that you can go back to if you need to.
But could you use it as like a basis for all your new VMs?
You absolutely can. And here, I'll show you that in a second. So 3. All right, done. So if I want to go back here and create a VM, and let's say that, actually, let's try something different there. I have to remember how to do that. Backups. Here we go. So if I did this, I could absolutely do a restore and tell it I want to do that. Or if I want to create a new, say I want to make that, so open this up here, we'll show the configuration. Let's see. Here we go. There's also the actual disks that are in operation right now. So let's go back up. I told it to restore. I could tell it what VM I want to restore it to as well. So if I wanted to do like a 5. See if this works the way I thought it would. Yep, there it is. So if I go back here, go back to this console on this virtual machine, start it.
Hey Shane, while this is running.
Yeah,
So the ultimate goal of this is to have one box up at your transmitter site with the transmitter that's doing all the functions.
right. And like I
Right.
said, I mentioned that the reason why a lot of people would shudder at that, but the reason why I'm a little more comfortable with it is because you see here, I have 2 nodes in the same box. It has robust storage. It has redundant everything, including redundant power supplies. So I could lose, several discrete components and still be up and running just fine. And again, there are systems that you can put in place to actually monitor all of that. Right now, I haven't quite gotten the failover done in terms of how to mirror all of these and fail them over to the other node, but it certainly can be done.
So
You say no.
Would this just be on a server computer of some sort up at the site then, or?
Yeah, exactly.
Nice box.
Yeah, it basically what you're looking at here, like I said, is a 1RU box that has 2 discrete servers in it, basically 2 blades that are completely independent. And what I did with ProxMox was I installed on both of them and made a cluster, so I could connect to either of them. So in fact, if I go, let's see here. Get that out of the way. So I go over to another, let's see, it's 10, oh, come on. 10.16. Let's see. So that's 201. This is going to be 202.
So we're talking satellite receiver, EAS box, audio processor, any other assorted deals that you may need.
Oh, wait a second. Maybe it was 200 and 201. Yep, it was. So this is actually physically connecting to, actually, this is my dev machine. This was my original dev machine. Let's take a look. What was that? Network. So it should be 202. 142, that's what it is. There we are. So now I'm actually connected to that other node, but you can see I can still see them both because they're clustered. So these machines are physically in the same chassis, and they're both running this hypervisor virtual environment, but they are clustered together in that virtual environment, so that they're basically talking to each other and saying, making sure that they agree at all times. And if one doesn't agree, then it basically gets kicked out of the cluster. It works best when you have three, but it also works with two. So.
Okay,
Yeah, go ahead.
operationally, if the person who set this all up and maintained it for years, suddenly went away and somebody else came in weeks later, how would they understand what all happened?
That's a great question.
So that's an excellent question. So it would be like any other IT infrastructure. I mean, document. There's a temptation to kind of make this stuff self-documenting, which works to a point, but you definitely want to have some kind of infrastructure, some kind of diagram that kind of details all of this in terms of what you actually do and what's where, passwords and things like that, or at least a way of recovering passwords if something, if the unthinkable happens, like tying it to your domain or something, so you can log, so you can authenticate that way. But the good news is that a lot of this stuff is getting to be pretty much industry standard stuff. I mean, you'll find people out there who know ProxMox, and you'll even find people who can kind of start to wrap their head around the specific broadcast applications that you might be running under it as well. So I guess that's kind of where I'm, where my line of thinking is, where I go with that particular question.
So I keep thinking back in a transmitter type environment, using the physical resources of the actual hardware for, audio in and out and, monitors, keyboards, mice, etc. How do you deal with that when it comes to virtualization?
That's a great question. So if you do have specific physical hardware that you need to allocate inside of a VM, that's one thing that ProxMox kind of is uniquely able to do. You can do hardware pass-through. So say you wanted a particular VM to always appear on the local display, from that physical hardware. And you wanted the local KVM to always use that specific VM on the local hardware. You can do that. In fact, if we go under our hardware here for these virtual machines, add, you could see that there's a section here called USB device, called PCI device. So let's take USB device, for instance. I'm not sure if I have, I don't know if I even have it. Oh, okay, I do. I do have a couple of things that show up as USB. So say I wanted to make one of those pass through directly to something else. I could do that. I could pass it through to that particular virtual machine. And same thing with PCI devices. So if I had there are some tricks. There are some tricks involved in actually doing this, but it is possible. So you can go through and you can look and see what's available on that system physically. And then let's say I wanted to, for some reason, let's say I wanted to pass through, let's say I wanted to pass through my graphics adapter. Okay, so do that. Primary GPU, et cetera, and I could add that and it would let me pass through the graphics adapter to that particular VM. So when somebody looked at the local console for that hardware, that's what they would see on that local console, even though in the background it was maybe running, See over here, a bunch of different other virtual machines.
Then they could use that local console to then interrogate ProxMox and the other virtual
Exactly.
environments.
Exactly. Yep. Or if you just wanted to maybe hide everything behind there and use it as a utility machine at the transmitter site, nobody has to know what's what's really going on in the background. It's just another computer to them. So as long as they don't turn it off.
Can you run OS 10 on this?
No, OS 10 is on my laptop. That's what I'm running right now on my laptop.
I was just wondering if you could virtualize OS 10 environments.
Funny you should ask. Actually, you can. I've not tried it yet, but that apparently can be done. So, although I'm not sure for how much longer, given Apple's propensity for changing things at the drop of a hat. So. Anybody else? Any more questions? Well, cool. If you have any questions, please feel free to reach out. Amanda's got my contact information. And some of you work with me. So again, feel free to reach out. You've definitely got my contact information. But no, I'm really excited about this, and I think it's going to be another great tool to add to your toolkit as an engineer. But like I said earlier, I mean, this is one example of how you can do it and completely control the environment. I don't have this, there's nothing relying on an internet connection for this necessarily, other than getting into it remotely through the VPN like I am here. But I mean, if you have it at the site, it's going to continue doing what it needs to do at the site, regardless of anything else, assuming it doesn't, assuming you've got some other kind of external audio source there, or some kind of backup source, should all fail. But yeah, this is one approach to virtualizing and keeping everything kind of under your roof, so to speak. And yeah,
Thank you. Very, very cool stuff.
Yeah, it's something. When I first saw this, I'm like, wait, do what now? And then it clicked. It's like, wait, I can run all of this in my on the same hardware. Wow.
Now, if you could only virtualize a 40 kilowatt transmitter.
We're not there yet. We haven't found a way to virtualize RF yet, unfortunately, but there are software defined transmitters. So watch this space.
Hey Shane, how many of the other pieces of equipment can be virtualized at this point? I mean,
I was literally counting this the other day, and pretty much everything you see in that rack back there, from top to bottom, pretty much, well, except for maybe the UPS. Okay, ignore the UPS. You can virtualize pretty much every component that's in that rack right now. Well, not currently, not right now, but it's coming. The only thing you can't virtualize right now is, say, the modulation monitor or the EAS system. Everything else can be virtualized. And that one, the EAS, is more a regulatory matter than a technical matter. Technically, it can be done, and it can be done easily. But from a regulatory standpoint, we're still working on that. But there are a lot of people who want to. So. But, yeah, that's my spiel.
Well, thanks to see you again, Shane. It's been a few years.
Likewise, yeah, absolutely. I'm hoping to get back out there to Denver at some point soon. So, and then maybe I'll try to make it a day when the chapter's meeting, so I can actually. I mean,
we'll make it July 21st, and you can have barbecue.
I may have to strongly consider that.
Thank you, Shane.
Yeah, thank you.
Yeah, thanks, Shane.
Yeah, thank you guys.
And thanks, Mike, Rich, and Jeff for joining us too on Zoom.
Thanks for having us.
All right. Well, I'm going to drop
Thank
off,
you, Shane.
guys. I
Good to see you.
I really appreciated it once again. So, and I'm always happy to present on interesting subjects like that. So,
Awesome, thanks.
all right. We'll talk to you guys later. Thanks.
Yeah.
All right. Bye.
Well, I guess that about covers it for us here. Again, if you guys did sign in, please, do that. Yeah, this is one of our best turnouts since, I guess, post-COVID. So thanks for coming out. Yeah, and then there's no meeting next month, so if you're going to NAB, enjoy it. Otherwise, see you guys around, see you in May.